Today we're going to talk about the parts of a good science experiment. So this is a science class. We're going to be doing a lot of experiments. We want to make sure that those experiments we do are of good quality. So these are the qualities that a good science experiment has. That science experiment will have background research, a hypothesis, specific directions, properly identified variables and constants, a data table and observations, a graph, and a conclusion. We'll talk a little bit about the conclusion in this video, but we will go way in depth into the conclusion in a different video. Now, doing all of these things distinguishes experiments from other types of science, such as observations. Not all science has been discovered doing big, giant, formal experiments. Some of them have been, more subtle, just observations, stuff like that. But when we do experiments, we want to make sure they're good quality. And when we're doing science where we are going to be discovering things in experiment form, we want to make sure that these are good experiments. So the first part of a really good science experiment is having background research. Now, background research includes any observations or information you get before the experiment, and this can be stuff you already know. This can be stuff from your textbook. This can be a formal research process where you actually go online or you go through books, you look for good sources to do that research with. You use that research to make your hypothesis. A hypothesis is an educated guess. That word educated is key. Without having that educated guess, your guess is just a guess. The educated is what makes it a hypothesis. And it's in a specific format. This format is if, then, and because. If, explain what the experiment's going to be about. Then, what do you think is going to happen with the experiment? And because, explain why you think it's going to happen. That why is based on your background research, what makes your hypothesis good, what makes your guess educated. So specific directions. These specific directions are most important for repetition and replication. Science isn't considered science until someone else has done the exact same thing and you've done it many, many times. You doing it again, repetition. Someone else doing it, replication. It's so, so important. So with these specific directions, you can make sure that when you do it again, or if someone else does it again, that it happens exactly the same way and they do the exact same experiment. Part of having specific directions is properly identifying your variables and your constants. So there are 4 types of variables and constants. You have what you change, what you measure, what you compare it to, and what you keep the same. These all have specific names. What you change is your independent variable. What you measure is your dependent variable. What you compare it to is your control. And what you keep the same is the constant. So when you're doing the experiment, you obviously have some information. You'll have both quantitative data and qualitative data. Quantitative data is numbers, and qualitative data is words. Most good experiments, great experiments, will have both qualitative and quantitative data. And so what you do with that data, if it's quantitative, which means it's numbers, you put it in a data table. This is just an example of a data table. If it's qualitative data, words, you just make sure that you take good record of what your words are about. Then you display the quantitative data. You display the numerical data in a graph form. And you've got a couple different graphs you can use. These are just a few: line graph, bar graph, and pie graph. Most often in science you'll see line graphs, but bar graphs and pie graphs have their place as well. At the end of the experiment, you'll come up with your conclusion. The conclusion is basically one paragraph that summarizes the entire experiment. It has information from each of the other steps in it, plus it explains how the results relate to the real world. What are we going to do with these? What's the plan from here? We're going to go into the exact format of the conclusion in the next video.